Before starting the lesson, try this warm-up question. The lengths in the triangle are all whole numbers. What are the missing lengths? And what is the length of x in this diagram below? There's x right there. These are tricky problems, so see how you do. These problems are probably not something that you're used to. Did you figure this one out? 3, 4. How did you know that? Well, we need to make sure that it lines up with Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. Also, you know that these sides have to be smaller than 5 because this is the hypotenuse. It has to be the longest side. So then you can basically just guess and check with different numbers that are less than 5. In this problem, you have a bunch of different right triangles all stuck together. And I looked at this first one. I know two sides, so I can use Pythagorean theorem to figure out the third. I've called it x. So 1 squared plus 1 squared equals x squared. Well, it turns out x squared is 2, which means x is the square root of 2. Now in the next triangle beside it, now I have this side is square root of 2, this side is 1, this side squared plus this side squared equals this side squared. And as you see here, it's a square root of 3. And if you keep that pattern going, this one's the square root of 4, square root of 5, etc., all the way to here, we find that x is the square root of 13. But that was just for fun because last lesson was about the Pythagorean theorem. We're going to go back to perimeter and area now. In this lesson, we're talking about perimeter and area of composite shapes. So we will look at what composite shapes are and how to find the perimeter and area of those shapes. So to start off with, a composite shape is made up of two or more basic shapes. So here's an example. I have a square and a triangle, both basic shapes. When I add those basic shapes together, I get this house shape. This is a composite shape because it's a combination of two basic shapes. When you're finding the perimeter of a composite shape, it's the same as we did for basic shapes. You're adding all the outside lengths. Now, sometimes people get stuck here when they're dealing with a composite shape because they try to add this line here, which would have been in the square, and they're saying, well, the square is part of this composite shape, so I'll add all the sides of the square. But really, that's not the outside of the composite shape. Only these lines on the outside are where the perimeter is. And to find the area of a composite shape, the simplest way or the most efficient way is to split the composite shape into basic shapes. So for this example up here, I would look at this shape and I would say, well, if I draw an imaginary line here, then I would have a basic shape, a rectangle or a square, and this other basic shape, a triangle. Then I would find the area of each basic shape using my formulas on my formula sheet. And then you either add the areas together to get the total area, or in some cases, you'll have to subtract the areas if you're taking away a piece. And we'll go through some examples of those. So here's my first example. Calculate the perimeter and area. Here's my shape. So first, let's find the perimeter of this composite shape. These lines mean that the side lengths are all the same. So this is a square. And this up here is what we call a semicircle, or half of a circle. So I know these are all 8 feet long, but what about this curved line? That's an outside line on this shape, so it's part of the perimeter. Well, remember, perimeter of a circle is called the circumference. And we have a formula for the circumference of a circle. This is just half of a circle, though. So if we want to find the length of this curved line, it's going to be half of the circumference of a circle with diameter 8 feet. So I use my circumference formula. Circumference is equal to pi times the diameter, but it's a semicircle. It's half of a circle, so I have to cut that in half. Now, when I do this calculation, I'll end up with about 12.6 feet. That's the distance along the curved part of the perimeter. So now I can calculate the perimeter. I add up the three sides of the square portion, 8 plus 8 plus 8. Then I add the curved portion, 12.6. And I end up with 36.6 feet. That's the perimeter of this composite shape. But now I have to find the area of this shape. So remember the strategy, split the composite shape into basic shapes. So here I have a square and a semicircle. Those are my basic shapes. So first I'm going to find the area of the square part of my shape. So area of a square, well, that's length times width. Length and width are both 8, so area is 8 times 8, which is 64. This is 8 feet times 8 feet, so our units are square feet, or feet squared. So this portion, the square part, is 64 feet squared. What about the semicircle portion? We need to find the area of that. Well, I know the area of a circle is pi r squared, and this is half of a circle, so I'm going to take half of that equation. So I'll divide it by 2. So it's pi r squared divided by 2. Well, what's the radius? Remember, the radius is not 8, it's half of the diameter, so it would be 4. So it's pi times 4 squared divided by 2. We end up with an area of 25.1 feet squared. So we have the area of the square part, we have the area of the semicircle part. Now to get the total area of the entire composite shape, we have to add those areas together. And when we do that, we end up with about 89.1 feet squared. In this next example, we're to determine the area of the gray region. So here we have, it looks like a trapezoid with a hole in the middle. So the area that we want to find is whatever is in this gray part around the circle inside the trapezoid. So our strategy for this one is going to be find the area of the trapezoid and subtract the area of this circle. And what we're left with will be the gray area. So use that strategy and try this question on your own. Pause the video, and then when you get your answer, check back in to see how you did. Area of a trapezoid is a plus b in brackets multiplied by the height divided by 2. When I plug in my numbers in the right spots, I end up with 1,881 millimeters squared. The circle has an area of pi r squared. Remember, the radius is half of the diameter. In this case, it would be 9 millimeters. So when I calculate the area of the circle, it's about 254.5 millimeters squared. Now, to get the area that's gray, I have to take the area of the trapezoid and subtract the area of the circle. I end up with 1,626.5 millimeters squared. And for the last example, wire fencing costs $12 per meter. How much will it cost to fence this yard? So here we have a diagram. There's a street and a walkway, another street, and a house. So if you're going to put a fence around your yard, is this a perimeter question or is it an area question? If you said perimeter, you'd be right because the fence doesn't cover the entire yard. That's not area. It goes around the outside of the yard. It's perimeter. Now, be careful with this question because are you going to put a fence along the house? No. You're only going to put the fence here, here, and here. There's dimensions here. We have it's 18 meters along the house, 14 meters along this street, 10 meters along this walkway, but I don't know how long it is along this street. So you're going to have to see if you can figure out how to determine this length right here, because you need that in order to figure out the amount of fencing that you'll need. So pause the video, try to come up with a solution on how to find this length right here, and I'll give you a hint. It has to deal with composite shapes. When I break this down in my mind to see that there's a triangle there, I can use Pythagorean theorem to find the hypotenuse. This is 14 meters down here. It's still 14 meters up here. If this part is 10 meters and the house is 18 meters, well, the difference is 8 meters. So I have this side, I have this side. I can figure out the third side using Pythagorean theorem. And it ends up being about 16.1 meters. So to find the perimeter of what needs to have a fence put on it, it's the 14 meters here, plus the 10 meters here, plus the 16.1 meters up here. I'm not putting a fence along the house. So I end up with 40.1 meters of fence. And the fence costs $12 per meter, so I have to multiply the number of meters by the amount per meter. 12 times 40.1, it's $481.20 to fence the yard. So hopefully you are getting a better grasp on composite shapes and how to work with them, finding perimeter and area. If you're having troubles, let me know and I can help. Otherwise, move on to the practice questions.